Welcome to a lesson with Dr. Powell. Let's take a look at how to find the distance between 2 points in the plane. Suppose we have a point, and suppose it's something like 1, 2, and we have another point right here. Maybe it's something like 3, 8. How do we find the distance between these 2 points? Well, there is you can look up a formula or something for it, but why not actually just use ideas of things that we already know? Let's first draw what we're looking for. We have a straight line. We want to find the distance of that straight line. Well, in a coordinate system, let's think about what we have. Could we draw a vertical line and a horizontal line and have a right triangle? Now we have, with a right triangle, we can actually say a lot. Maybe we don't know exactly what this length is, but we should be able to figure out what the other lengths are fairly quickly. What's the length of this? Well, think about what this coordinate means. This means that the height, or the y value, up at the top is 8. And the y value right here at the bottom is 2. So what's the distance between? Well, think the distance on a number line between two things is just the difference of the two. 8 minus 2 would be 6. What about this distance right here? Well, you have an x coordinate of 1, and we have an x coordinate of 3. So the total distance here would be 3 minus 1, which would be 2. So it's like we have a right triangle with a length of 2 and 6. Now, how do we find this? We find it using the Pythagorean Theorem, which states that, normally, many of you might think it's just a squared plus b squared is equal to c squared. I tend to like ideas rather than formulas sometimes, and so that's the way I will teach. In a right triangle, there's one side length which is called the hypotenuse. That's the side length that's opposite the right angle. And the legs are the other sides. I think hypotenuse is hyper, so it's it's away from it, the right angle, or away from what's right, I suppose. Okay, and then we have the legs right here. So the Pythagorean theorem states precisely that the leg squared plus the other leg squared is equal to the hypotenuse squared. Or I'll just do it like that, hypotenuse squared. So remember, in our triangle, we had a side length of 2 and a side length of 6. And we're interested to know this. And we can call it whatever we like. If you want to call it c, that's fine. So think about what this formula tells us. This tells us that 2 squared plus 6 squared is equal to c squared. I like to do this because sometimes we actually use various letters for different sides, even a c for a side length. And so I don't like to think of a, b, and c. Rather, I like to think about the ideas. Leg squared plus leg squared equals hypotenuse squared. You won't mess things up if you always think about the ideas, because labels are arbitrary, and we could have used a c anywhere along a side. And we'll see examples of that later in this class. Therefore, I want us to think a little bit about ideas here. So using that, we simply have 2 squared plus 6 squared is equal to c squared. Now to find c, well, we just add. So 4 plus 36 is 40, and take a square root, and that would be equal to c. That is the distance between those 2 points. It's the square root of 40. Now, this honestly is just fine for me. You may have seen in another class that you want to simplify that, but for me, that's fine. If you did want to simplify it, you could think of it as 4 times 10, and think 4 is a perfect square, so it'd be 2 square root of 10. But again, square root of 40 would be just fine for me. Thanks for watching.